Okay, so we're going to continue talking about bone growth. I just wanted to show you that because of the whole epiphyseal plates versus epiphyseal lines thing, you can totally tell on an x-ray whether someone is finished growing in long bone growth, in interstitial growth. So you can see epiphyseal plates still present. For instance, that's a really good one right there. Whereas if the person was fully grown, those would have been sealed. Okay, but you don't just grow in height, your bones also have to get bigger, right? But so bone growth in diameter is pretty easy to understand. It's called appositional growth. It really is a net gain in bone mass because, of course, if you compare a newborn to an adult, you are going to have a lot more bone mass. But in addition, the medullary cavities of your long bones also get bigger. So what tends to happen is that on the outside of a long bone, there is more osteoblast activity. And on the inside of a long bone, there is more osteoclast activity. So not only is the bone bigger and more massive because there was a net gain, there is also a bigger medullary cavity. Okay, so bone growth in diameter is called appositional growth. Okay, so how about in adults? What do your bones do? We tend to think of our bones as kind of being done as adults, but they're absolutely not done as adults. What's happening in adults is you constantly have this sort of dance between osteoblasts depositing more bone mass and osteoclasts breaking down bone mass. So you've got constant deposition and reabsorption and deposition and reabsorption. But as long as the process is balanced, you don't really ever notice it. Think of it like your bone being your calcium savings account. Sometimes it might be slightly low, sometimes it might be slightly high, but if you had a goal to keep X amount in your savings account, overall it would be relatively constant. Okay, so the process is usually balanced, so bone mass does usually stay constant for a while until you get older. Okay, so that is assuming, though, that you have all of these things that you need in order to maintain your bone mass. You don't have to memorize this because it's in your notes, but this is also table 6.2 in your textbook. So in order for an adult to have healthy, normal bone mass, you need nutrition. You need vitamins A and C. You need vitamin D for calcium absorption. You need proteins to make the proteins in your bone. You need calcium as well. Okay, and then there are some hormones that are involved in regulating bone mass, and not just sex hormones. So sex hormones are important, though. After you start using your sex hormones to build your bone mass, you really need to keep them or else you're going to start losing your bone mass. That's one of the reasons that, for instance, a postmenopausal woman can start to be concerned about losing bone mass. But there are also other hormones. There are the calcium regulating hormones. So calcium is really important for a bunch of things, not just for maintaining your skeletal mass. As I've mentioned before, it's important for nervous system transmission. It's important for cardiac muscle contraction. It's important for a whole bunch of stuff. So if you ever need calcium for one of those body systems, you're going to remove it from your skeletal system. So how do you know when to make a calcium deposit versus when to make a calcium withdrawal? Well, there are two hormones. This is a little negative feedback homeostasis. It's an example of something that you'll see a ton in physiology. So there are two hormones that are really, really important for regulating your calcium. They both act on osteoclasts, which seems kind of counterintuitive, but I'll be able to explain it to you. So if you click on this hyperlink right here, there's just a little drawing that I've already done for you. Okay, so if you were looking at regulating your blood calcium concentration over time, what you would see is, so let's say you ate a really calcium-rich meal. You had a cheeseburger, you had a milkshake, and broccoli, which also has calcium in it. What would happen is your calcium would start to raise. You see this? Okay. And as it raises, that will cause the release of a hormone called calcitonin. I always remember what calcitonin does because it tones down your calcium. And what calcitonin will do is it will say, oh, okay, I don't need to make any more withdrawals from my calcium bank, so let's slow down my osteoclast activity. And therefore, the osteoblast will sort of catch up more, and the osteoblast will sort of do a more of a net deposit. And then your calcium will start to fall. And then let's say you haven't eaten for a while, and you are starting to get low on blood calcium. Then your parathyroid glands will release parathyroid hormone, PTH, and PTH increases osteoclast activity. And again, it doesn't bug your osteoblast. They're just sitting there minding their own business, but the osteoclasts sort of overtake them, and they have a net gain, not a net gain, a net removal of calcium from your bone matrix, and they dump it into your bloodstream. So whenever calcium is high in the blood, you release calcitonin. Whenever it's low, you release PTH, over and over and over. And this is sort of how you decide whether to make a deposit or a withdrawal from your savings account each time in order to keep your blood calcium in this ideal range that you see in red right there. Okay, so let's see if I covered everything on your notes. Okay, if calcium decreases below normal, like if you have poor nutrition or no vitamin D, then your parathyroid glands secrete PTH, and it stimulates osteoclasts, and you release calcium into the bloodstream. If blood calcium increases above normal after you ate a rich meal, thyroid gland secretes calcitonin, and it inhibits osteoclast, and the osteoblasts end up making a net deposit. Okay, what about the sort of use it or lose it of your skeletal system as an adult? I know that you have been an adult long enough to know that if you don't use your muscles, you lose your muscle mass, right? So you can work out and you can get your muscles all toned, and then you start feeling like a garbage truck. And so you take a break, feel terrible, and you lose your muscle mass, and you see it happen all the time. But the same thing is happening with your bone mass. So what your bones do is when you talk to them via stressing them with mechanical stress, they say at that point that you pulled on me because you've been doing deltoid exercises or bicep curls or whatever, at the points of attachment, you are communicating to your skeleton, I need you to be stronger there in the future. And so what happens is bone will respond to mechanical stress by growing and remodeling to become thicker and heavier. So the bony projections, the depressions, all of those things that you're learning in lab, all of the little processes and fossas and everything, they actually become really pronounced in people who are doing a lot of weightlifting, a lot of mechanical stress on their skeletal system. But the opposite is also true. When a bone is casted, it loses mass because you're not giving it mechanical stress. If a person is bedridden, they can lose bone mass. If a person is immobilized by an accident, like a paraplegic person or a quadriplegic person, they will lose bone mass. Astronauts, when they go up on the Mir space station or the International Space Station for long periods of time, will lose bone mass as well. So why does this work? Basically, the site at which you pull on your bone when you're mechanically stressing it, it bends the bone a little at that point. It produces an electrical impulse which inhibits osteoclasts and stimulates osteoblasts at that point. And so it helps to grow the bone at that point. That's one of the reasons that you can use artificial stimulation to speed the healing of fractures. And fractures is what we're going to talk about next.